So, last time I explained briefly what Java is. It's a programming language, a way to talk to computers, right? A couple main things with Java. I'm actually going to go back in time here a little bit in terms of what we're referring to. But if you remember in lesson 1, we went over what is Java programming language. We need to tell computers specific instructions. But to do that, we need to talk to it in a form of grammar, and that is syntax. Just like English has its standard conventions, we have to give it a standard convention to communicate with us, and that's syntax. So classes, I can explain that later, but the main part is just making sure that that is always capital M main as your starting file. And the next thing is that every single argument, every single thing you say to it, to the computer, to talk to it, it must end with a semicolon, if you remember. And then when we went over output, we just went over the boxes, if you will, the comparison between how each bracket is like a block of code, and each dot is showing that those boxes are inside of each other. So system is its own box. Actually, hold on. All right. System is a whole box. Out is a box inside of system. And print is another box. And each box contains, the entire system box contains all of this. We have to go through the boxes by using a dot. That is the basic ideas of a method. It's just boxes inside of boxes, or in this case, telling the computer what to do and where to find it and how to find that certain method. So we go over printing. Basically, it's just the way to tell the computer output this, right? And then comments and variables. So I'm going to start at variables. If you look, sorry, what was your name again? I'm so bad with names. Angela. Okay, so if you opened up the W3 Schools Try It Editor, did you open that up on Google Classroom? Yeah. Okay, so then you should see on the very bottom there's a lot of lines that say like system.print.out.print. Basically what that's doing is it's telling the computer to print what's inside the parentheses. So I'm going to go over how you tell it what to print and what kind of things you can tell it to print. So usually you tell it to print variables or types. So if you look on the W3 Schools Try It Editor or whatever, you should see that you should be met with something like this. So up here, these are variables. So different kinds of variables that we can talk about and types. We're going to start from top to bottom, quick review. Integers, whole numbers, 1, 2, 3, 4, 0. Those are all integers. Floats, decimals. It's another nice way of saying like a small decimal. So 5.99, that's a float number. However, 3.14159265535, that's a double. And they're just another way to say it's a long decimal, basically. Car, it's a character, same thing on your keyboard. So D is, like for example, that would be a character or car. Booleans, true or false, 0 or 1, electricity on, electricity off. So basically, if I were to evaluate, let's say, is my computer on the table? Then I'd say, yes, true. My computer is in fact on the table. So, and then strings as well. So that's the main thing that we're going to be printing out when we say system.out.println. That's where it says hello world normally for most programming languages. It's just any combination of letters that resemble words inside of these quotation marks. That's going to be a string. And if you look on the W3 Schools Try It Editor, you'll see that all of these types, they have like a special highlighting, a special color to them. That's how you know that you're interacting with a type and that you've actually spelled it correctly. For example, if I go to the W3 Schools Try It Editor myself, going through the Google Classroom and onto the assignment, then you'll note if I were to spell string down here, then it doesn't actually highlight the correct color because I'm not interacting with a real Java type. String without a capital is not the same as capital S string. So it's all case sensitive. That's what we refer to as case sensitive. It means capitals must match. Spelling must match. If you misspell something in Java, then you're going to spend a long time looking for what you misspelled because it will not run if you misspell something. So I'm going to go ahead and delete that now out of this line. And then you'll notice here, I was talking about variables last time, right? So strings, I kind of explained that general thing, but here, again, I just want to reiterate the fact that this is a data type. This is the actual type of argument or variable that we're working with. So that's all of these on the left. This is the variable name. So if you look on W schools or whatever, W3 schools, you'll see that it says like my int or my float, my string, whatever. Those are names that you set as the developer to refer back to like in your head. So it doesn't actually have any effect on the final product. What's in that right output box on the side has no effect on that. The only thing that it has an effect on is just what you refer to it as in the code. So you need to consistently refer to it as the same thing once you set it to a certain name. And then the value, this is the main thing that we change. So the reason why we use variables is so that we can dynamically change this value. So in this example, it's the number 20, but in the example of Christopher High Robotics, it could be velocity, it could be the movement, it could be where we are in terms of the field, anything like that. And then next thing as well is types. So when I refer to types, what am I referring to? Again, I'm referring to all of these individual like variable names, like the kind of variable they are. That's what I mean when I say types. There are primitive types and there are non-primitive data types. So when I'm interacting with primitive types, these are bytes, shorts, integers, longs, floats, doubles, booleans, and cars. So for now, that just seems like a very long list of names that may not make a bunch of sense, but generally the only, I shouldn't say this, but I'm going to say it anyways. The only important ones are integers, doubles, and booleans, realistically. Especially when it comes to practical programming and what Christopher High Robotics does in our competitions. So, as I said, I'm actually going to take a volunteer here real quick. What's an integer? So what's type int? Any volunteers? Any volunteers? I know.
A number.
A number? What kind of number?
0, 4, 6.
Yes, whole number. So when you use an integer, this brings me to my next point. We have to, when we convert numbers, there's got to be a way to change a double, a decimal, if you will, to an integer, right? And vice versa. That's when typecasting comes into play. So if I wanted to say change 3.1 to a integer, a whole number, then I'd have to change it to be 3, right? So Java will automatically do that for us by using what we call narrow casting and widen casting. It's okay. So when we widen, we're converting it from a smaller type to a larger type. So if you recall, when I was talking about floats and doubles, for example, I was saying that floats are a small decimal. That's like 3.99, for example. Doubles, they can be very long. They can be, I think, up to 16 numbers, actually 32. So that can be, 3.1411, so on and so forth, right? When you convert from a float to a double, you are widening the variable type. You are expanding the amount of numbers that you can use. when you're narrowing it by casting it to a narrower type, then you're switching from something like a double to an integer. A double can hold, as I said, up to 32 individual numbers and like decimals, so on and so forth. Integers can hold only 16 numbers and they don't have a decimal in them. So that'd be out of scope anyways. So if I go here, I'm going to show an example. So here's what it would look like when you're actually programming. So if you want to go to W3 schools, then you can try it out with the existing myInteger, assuming that's what it looks like. Oh, so mynum, actually. If you typecast mynum to be an integer of, let's say, 3.1, for example, then what it's going to do is something called truncating. So truncating, just a fancy programming word. All that happens is we convert something like, let's say 3.141. That is a double, right? This is kind of a longer decimal number. So what we do when we convert it to an integer, and more specifically what Java does, it just slices off this front half. From the decimal point on, it just slices it off. There's no rounding, nothing like that. It just slices off everything from the decimal point on. That's the best way to think of truncating. So for example, if I have 3.91, do I have any volunteers for what this would be as an integer? Yes? 3. Exactly that. No rounding, no funny business, just slicing off the number from the decimal point. So, when you're wondering what happens to a decimal when we switch it from a integer to a decimal, all that happens is we add a 0.0. So if you want to follow along, you're welcome to. I'm going to create a new variable, so that's going to be a decimal number, aka a double, right? So I'm going to say double my dub is equal to. So first things first, I have the type, I have what I'm calling it in the actual programming like area. I'm having the name of it, the variable name, and then I'm setting it equal to something like, let's say 3.14159. I don't know, you can go longer, right? What happens when I set this to an integer is it just truncates at 3, right? But let's say I create another integer now. So I'm going to say int, my int is equal to 8, right? And just in case you forgot, make sure to add semicolons at the end of every single statement. That includes this one. We must have semicolons. So if you didn't, go back and add a semicolon. So if I convert my int, so I'm going to say system.out.println, and what I'm going to do is called manual casting. So manual casting is when we basically put the type that we want. So let's say I have this here. This is going to be my whiteboard now. I'm going to manually typecast one type of variable into another. And to do that, I just put parentheses, and then I put the desired type. So let's say I'm going to turn this into type double. And then I'm going to close the parentheses. And you can think of this like multiplication parentheses. I'm going to multiply what's in front of it. So you wouldn't actually type this part, but you just put double, and then you put whatever integer you have. So let's say double 3, that'll convert it to 3.0, because now we've expanded it by using typecasting to go from just the number 3 to 3.0. That way, if we add 0.1, we're not trying to add 0.1 to just 3, because Java doesn't understand that. It's adding 0.1 to 3.0, and now you have 3.1, right? So if we go back, and first things first, I typecast integer to double, you'll notice that one, it highlights it because I'm using the correct type. And then I'm going to say my int. And for reference, that space was just so that you could see it. Just a quick thing about programming languages, they don't actually care about spaces. What a computer sees when it sees a space is nothing. So the only thing that it actually cares about is the enter, so new line basically, having things on different lines, and semicolons. That's for this language in particular. Something like another language like Python might not work out so well. But it just considers it white space. It doesn't see it because it has no use to see spaces. So if I run this, then you'll notice I don't have a semicolon. So make sure to put semicolons again. The console here will tell you if you make a mistake like missing a semicolon. I'm a frequent offender, I will admit. I think I spent probably at least 2 hours just fixing semicolons for Christopher High Robotics. Then you'll notice that an integer cannot be converted to double. So this is what's known as a type error. So in essence, when we're narrowing, I just want to go through this now. When we narrow a type, or we expand a type, we have to do it. Java will not understand what we're doing if we try and widen a type like integer by using manual typecasting. So that's why you have to set it to a new value by getting rid of this here. And instead we'll say my dub is equal to my int, and then Java will automatically do it for us. So what we just did here is we got rid of the number right here. We got rid of my double, and we just sent the value of my double equal to 8. But we know that my double, or my dub, is equal to a double, so it'll automatically convert that for us. And then we typecast here first though. So here, double. Alright. Alright. Anyways, moral of the story, it's still not working. I'm gonna blame it on W3. Typecasting is not that big of a deal generally, but it's kind of a special circumstance when you're converting integers to doubles. Generally, Java will do it for you though, so don't worry too much. But I'm just going to brush over that. So anyways, the main actual important part of Java, how do we get it to perform complex calculations? That's going to be through the use of operators. So we talked about how we can add in Java. I was talking about adding 3.0 to 0.1, right? So we get a 3.1. Now, of course, that's a pretty simple calculation. Most people in Math 1 and above should be able to do that. Even below that, probably be able to do 3 plus 0.1, right? But numbers get much, much larger, and they change very quickly. So that's why we use operators. So you'll note that we have addition, subtraction, you're familiar with these. And then, as I talked about last time, multiplication uses the asterisk. So that's going to be Shift 8 on your computer keyboard. The next thing is division, so that's just a slash. It's in the bottom right of your keyboard. The next thing I want to talk about is modulus. I'm not going to go into depth about modulus because from what I have personally used in Christopher High Robotics, it's not that important. But basically, it's just the remainder for division. So if I were to do, let's say, actually, hold on. If I were to say, do 7 over 2, then I know that 2 fits into 7 3 times, right? But we still have one number left over, right? Still 1 over 2. So instead of doing like a complex fraction or anything like that, all that modulus returns to us is 1, because that's what's left over when we divide 7 by 2. We know that it fits into 7 3 times. We get 6. 7 minus 6 is 1. That's modulus. So if you're asking what use is that, it's good for determining like even numbers, odd numbers, and any number of complex patterns when you're programming and dealing with a large quantity of data. But generally, increment, decrement, multiplication, division, all of that, those are your main operators. So you can just say plus plus, minus minus, and we have these comparison operators. So the main part of Java and one of the main functionalities is to be able to compare two numbers. That's a huge part of what Christopher High Robotics does. So for example, we need to be able to check if numbers are equal to each other, if they're not equal to each other, if they're greater than each other, if they're less than each other, so on and so forth. So as you can see, there are all of these. You should be mostly familiar with greater than, lesser than comparisons, possibly in Math 1. I know that the greater than or equal to does not look like this in Math. It has the little line under it. We can't do that in Java, so we just stick an equal to right next to it. It has to go comparison operator and then equal. So it's greater than or equal to, so on and so forth. The next thing is these. So this is called an ampersand, and this is called a pipe. If you put two ampersands next to each other, it becomes and. So when we get into if statements, probably next week, that's going to help us compare two things at the same time. So if my computer is on the table and if the HDMI cord is on the table, then it is true. But a logical or is kind of like the opposite of that. It's an or. So if my laptop bag is on the table, or if the HDMI cord is on the table, then something would be true. It doesn't matter. It could be both of them on it. It could be one of them on it. That's the difference. And then you'll see this a lot. This exclamation mark, it just means not. So it's doing the opposite of what you would expect it to do. So for example, if it's not and, then we have a NAND gate. Getting into logic gates, you'll learn about that later, possibly in school. They kind of go into it if you go through the computer science program. If not, then you might just find it out elsewhere in the world. But basically, it's going to say if both of these are not here, that's when we would use a NAND gate. And it gets more in depth, but basically these three things right here are what make up all of your computers. Transistors and zeros and ones, that's how we transform data into something that's tangible, something we can see, and basically it's just a bunch of these ands, ors, and nots going on really fast to do all the math in your computers. At its most basic level, so I remember like 2 years ago I created a calculator out of just logic gates, so and, or, and not, combinations of those, and you can create a binary calculator, so on and so forth. But anyways, that's all the content that I had to cover because I feel like right now I'm just kind of talking when in reality there should be some sort of end goal. What can you do by the end of this camp? What can you understand and what can you work towards, right? So I'm actually going to get the robot out to kind of show it off because Christopher High Robotics has been working on this for our whole competition season, and it uses Java. So maybe I'll get into the code base a little and show you where some of these comparison operators and addition and so on and so forth operators are being used. So I'll be right back. It's actually not far.